Working on. Hi, everybody. Smitty Halibut here. Starting up another Smitty working on something. Tonight I'm going to be finishing off, or I don't know if I'm going to be finishing off, but I'm going to continue working on my Enigma emulator. It's been a while since I've done that and worked on it at all, so I actually went back and watched the last little bit of the previous episode of this. Goal on this is to make a device that is electrically very similar to the Enigma, but instead of using physically rotating wheels, I'm going to be emulating the rotators with a microcontroller and a display. But I wanted the interactions of the buttons, the lights, and the plug board to be as accurate as possible to the way the Enigma actually worked. And so I ended up, let's see here. Nope, where is it? There it is. I ended up working on, or kind of coming up with this. So the way the Enigma worked is that you had power and you had a light and going down to ground, and then a button that would select that. And this was the plug board, and then the output of the plug board would go into the rotators. So this is the rotators over here, and basically you can view the rotators as an arbitrary mapping between any two pairs of letters. Like, for example, if A and M were mapped together on the current state of the rotators, then M would also be mapped to A, so it would go both directions. And then the plug board was more mapping, and it's just kind of a way of jumbling things up. But because it was symmetric, the way it worked is you would push a button, and by pushing a button, you end up connecting that letter up to power. And that power would then go through this letter, it would get mapped through the plug board, it would go through and get mapped through the wheels and come back on a different letter somewhere else. And you'll notice that all of the other letters are tied to ground. So let's say for M, for example, they're all tied normally through the normally closed side of the switch, through a light, and then to ground. And so that's how the Enigma worked, is that it just had these rotators that would, the rotors that would map one letter to another, and it was always a symmetric mapping. And in that way, you could actually reverse the process, because when you typed in, like if to encrypt, let's say you typed in an A and that mapped to an M, right? So you would push the A button and the M light would show up. But if the rotors are in the same position, and your plug board is in the same position, i.e. the state of the machine is the same, if you push down on M, it will light up the A side. And that's how you would encrypt and decrypt, by just putting the machine into the exact same state. And if you put in clear text, you'll get the ciphertext. But if you put in the ciphertext, you would end up getting the clear text as well. So the machine, as long as it's in the proper state, gets both of those. And so that's what I tried to emulate here with this schematic diagram. And you have one of those for every single letter. There are only 25 of them. I can't remember what letter it is that they leave out. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, no, there are 26. I don't know why I thought there were only 25. Maybe that was a different scheme I was thinking of. Anyway. And instead of rotators, we are going to be using a microcontroller. So here are a couple of MCP 23017s, which are basically just a bunch of GPIOs on one side and an I2C bus on the other. So what that's going to do, and you can set the address of the different chips through these adder pins. And so all three of them tied to ground are going to be 000. This one's going to be 100. So this one will be one address higher than this one, and that way you can address each of these chips individually. And I've even got a few extra GPIO pins over here. Whatever will I do with them? I don't know. But that means that all I'm trying to do right now is test the rest of this. This means that I can hook it up to just about any microcontroller. So I'm not actually putting the microcontroller and display on this board, because I'm kind of assuming that I'm not going to do anything unique there except in software. I'm not going to be doing any unique hardware. It's just going to be a standard, I don't know, maybe a ATmega 328p, because we don't need a whole lot of horsepower. I mean, heck, we can probably even do it on an AT Tiny. And then just a normal display, like a 2x16 LCD, or maybe one of the little 0.19 or 0.96 inch OLEDs that are real popular that we've been using for the Darknet badge, something like that. I don't know. That's a software problem. As far as I'm concerned, the rotators and all of that stuff is going to be handled separately. Although, come to think of it, we are going to need a few buttons for setting rotator status. So I could put buttons on these and use those for that. Okay, I'm not going to worry about it now. Whatever micro we use, we'll have enough GPIO for that. I just didn't have 26 GPIOs that I could use for each of these letters. So for this board, all I'm doing is the keyboard side of things. The display and the micro and the smarts and everything else will be done in a different board. And again, this is just a prototype. This is a proof of concept. Make sure it works. Make sure the design is sound. And then after we have all of the different pieces working, we can go ahead and lay out a final board. This is the board layout that I had at the end of last episode. We've got the LEDs at the top in the grid. You can kind of see like K. Oh, there it is. Like Q, W, E, R, T, Z, so on and so forth. It's not quite a QWERTY keyboard. It's a different keyboard that the Germans used. This is where the buttons go. It is hard to find single pole dual throw buttons. And they're not cheap. I ended up buying these parts. They're from eBay. I think they're a little less than $1 a piece. And they are... thought I had one that was open. They're kind of the same physical layout as the pretty typical 3-pin switches, like lever switches. Shoot, I should have opened this up before I started the stream. They're commonly the same layout as the commonly available switches that you can get for pretty inexpensive as well. But they are single pole, dual throw, momentary switches, which is exactly what we need for an Enigma. If I can get it out of the package, I can show it to you. I also want to measure it to make sure that this layout has them far enough apart so that the buttons don't run into each other. So that's what they look like. I don't know if it's going to focus or if it's going to whatever. But there are 3 pins on the bottom, and they are common, normally open, normally closed. And if I remember correctly, that's how I wired these. Common, normally open, normally closed. So it should be pretty obvious as to which side you put that in. These are normally meant to have little pieces of wire soldered to them, but the layout here is done specifically that you can just solder these straight onto the board. And then it's got, little button head at the top. You can hear it clicking. Clicky, clicky, clicky. So let's go make sure that we've got enough space between all of these. Zero my caliper. And the head appears to be 3.8 inches or 0.38 inches wide. So I need to make sure it's at least 0.38 inches center to center here. Okay. So that's a 5.85. And that's a 6.25. So I've got, what is that, 0.4 center to center? And that will be just barely enough. And if I pull my calipers out to 0.4, then I've got just a little bit of wiggle room. I don't know if that's going to be very convenient as a keyboard, but that's what we're going to go with for testing at least. Because I don't want the board to be too large, because then it gets expensive to fab. As it is, this is going to be pretty expensive to fab. All right, so if we look at the schematic is that we've got ground through the resistor, through the LED, to the switch, to at least one pin of the switch. One of the other pins of the switch goes to VCC. So I've got a plane here and I got a plane here, but I need to run traces between all of these. And then another trace from here down to the patch panel, and then a trace from the patch panel down to the chips. So it's going from top to bottom. It's going from resistor to LED to switch to patch panel to the chip. And that will be super easy to lay out. However, it'll be somewhat hard to use because your keys will be in the middle of the board. It's usually better to kind of hold the board in your hand and have the keys, the buttons, within easy thumb reach from the bottom. Ideally, the buttons would be at the bottom, the pegboard would be in the middle, and the LEDs would be at the top, but that would make routing very difficult because then I have to route to these chips, and these chips will be right in the middle of the things. It would be easier if it were switches and LEDs and then plug board at the top. So if we move to the plug board to the top of this and then put these chips at the top of that, that might be doable. Let's take a look at that. Where's my rat's nest? Turn on my rat's nest. So if I take that, all it has to do, so it would go from LED down to switch and then from the switch back up. That wouldn't be too hard to do. That's a gnarly rat's nest. All right. Because this is a prototype, I'm going to leave it the way it is. I want to make it somewhat easier to fab and lay out and everything. And then when we do the final product, we will actually lay it out in a sane way for people to use. Okie dokie. So let's start laying some traces here. I'm on the copper layer. So that's ground. So this is going to be pretty easy. Doo-doo-doo. Oh, oh, so close. So close. One of the things that's very important when figuring out where to place components is to think of ways to minimize the traces. Put the components that are going to be connected to each other close to each other, as close as possible. I mean, without crowding, but, you know, to the, oh, that one is off. Why is that one off? What's off? Is this off? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Huh. Why is that resistor off? That one is flush with that, and that one is not. Okay. Anyway, layout components, like I was just talking about, if at all possible, to minimize the length of traces and the number of traces. You also want to look into trying to minimize the crossing over of traces. My preference, whenever possible, is to keep one side, usually the bottom, completely free of traces, or as completely free of traces as humanly possible, so that it can be just a solid plane, be it power or ground or whatever. Like I'm probably going to do ground on the top because these are surface mount and these are all on the top. Although, shoot, as soon as I start connecting these, they're going to be chopped off. So we'll figure it out. We're going to figure out where all this stuff needs to go. And redraw because that was ugly. And then that one will come over here, maybe? All right, can I keep that pattern up? I'm going to have to move that over. Because that way, because I need this one to be able to come like that over here. This might be difficult, but we'll make do. So my concern is whether I'm going to have a clear path to get the bottom side of these out. We'll figure it out. We'll go on the bottom layer if we have to. So this one's going to go there and straight in. And then, so ideally, just because I'm a sucker for symmetry, ideally, all of these traces would look the same. We'll see whether I can actually make that happen or not. Hey, so close. Apparently sports ball is happening in the house next door. Yeah, these traces are not the same. Yeah, that's all right. They don't need to be. I'm just a sucker for symmetry, so that's the kind of thing that'll bug me, but it won't make a darn bit of difference to the electrons. Everyone having a good night tonight? Anything exciting going on in the world I should know about? What kinds of projects are y'all working on? Hit me up on Twitter and let me know. At Smitty Halibut on the Twitters. Oh, whoops. Forgot one. And let me know what kinds of awesome projects you guys are working on. I want to know. What? Redraw. Thank you. Okay. Got that one. This one next. I wish it was consistent as to when it decided to redraw, to auto shift the screen, and when it didn't, when it decided not to. All the dogs. My wife corrects me. Nope, just one dog. Do-do-do-do. The big advantage to symmetry on these is that once you figure out a way to route one, they all route the same. Okie dokie. So let's take a look. The ground plane's going to go to the resistors, and we haven't cut off the ground plane because the ground plane will come in through there. Then from the resistor, the LEDs, from the LEDs down to the switches. I'm going to put VCC on the bottom plane, which doesn't have traces all over the place, so those will be able to get through. And then now it's a matter of connecting the commons down to the plug boards. Well, we have to do basically the same thing that we just did, but with things going all directions. Oh, that'll be convenient. And then nope, can't do that. All right. Let's see here. I'm not going to be able to do this. I'm going to have to zigzag a few times, I think. Okay, I think we'll be able to make this work. I'm going to have to do a little bit of zigzagging here and there. And then terribly exciting, isn't it? That was ugly. All right, that cleans up. You know, don't they have auto routers, Smitty? Well, yeah, they do. But I'm pretty convinced that an auto router would not have done this nearly as cleanly. Probably would have been an awful lot of, oh, we'll just throw this over here, we'll just throw that over there, because, you know, who cares? It's all a digital signal. I'll be honest with you, I have never once used an auto router successfully. Oops. Almost there. Stay on target. Oop, damn it. There we go. And I'm just going to go wide on that one because I can. Okay. Let's do a DRC and lots of unconnected pads. VCC, oh, no, okay, no, that's not going to work. All right, let's do this. Give me some edge cuts. Let's define a border to this. One, two, three. Oh, blast. What is that? 545. 5475. So 545. Okay, so I actually want to go. Whoop. 545 going to be enough? Yeah. Okay. Get it out of the text box. All right. How big is that? How much money are we looking here? Oh, 1475. Okay, fine. So 1.5. Okay, what's the top? So what I'm doing right now is I'm just anchoring it onto blast. All right, let me go up to. I'm trying to anchor it on nice round numbers so that I can calculate sizes of things. Okay, I want to go back to. I want to go back half an inch this way and 0.175 up. Okay. Where am I? 545. So I want to go that way by half an inch. Oh, sorry, camera's backwards. That way by half an inch, and that way by 0.2 inches. So I want to go to 325. So let me go up to 125. And 545. So I want to be at 495. .325, and I set up by 2, so 125 and 495. Okay, that right there should anchor this at 1 inch and 1 inch. Ah, so close. Gotta move the Y down by 1. There we go. All right, so now my my X and Y down here are 1 and 1. Oh. Hey, Akash. Oh, boy. Your Jesus. Hi, your Jesus. You're not really welcome here. That's not what this is all about. Can you make videos going behind the digital domain in your thinking process, explaining the idea? Sure. What specifically are you talking about? Give me some examples. What is it that you would like to see an explanation of? Technically, what I'm doing here is digital, but it's kind of analog-ish. But if you go into a little bit more details, I'd love to hear what you mean. And because of the delay in the chat room, I'm going to get back to working on this while you reply to that. Okay, so that's 1 inch by 1 inch there, which makes that easy to figure out because now I can just go down here to the bottom of the board and say that is 4.6 and 6.9, which makes it 3.6 by 5.9. And if I do that, easy myself, 3.6 times 5.9 is 21.24 square inches. $5 per square inch, so it cost me about $106 to get 3 of these made. Oh, kind of expensive. I can probably compress the lights and the things down, but for right now, I'm just going to suck it up. Alrighty-o. Let's dive in here and connect these up. Where do you go? Copper layers only. Oh, sure. All the way over there. That's not going to work. Yeah. So, this is where we get to go to the schematic and assign letters to where they go better, more intelligently. Because it doesn't really matter which letter goes to which of these pins. Oh, I just did them alphabetically. That's definitely not going to work. Apparently I left my water bottle in the other room. So it doesn't matter which of these pins I assign these letters to because it's all software. The mapping is going to be done in software. And so it would be a heck of a lot better for me to map which pin goes to which letter based on what it would make it easier to route. Since I can do all of the mapping in software, that won't be a problem. So let's take a look at this. So A, B, C, D, E, F, G, H. Okay. Well, that's unfortunate. So it sounds like all the letters are on the pin one side of the chip over there. Okay, so what I want to do is something like the bottom row. I'm going to have to like interleave bottom row and top row as to whether they go, because I got 3 rows here. I got these 3 rows that I'm going to be mapping to 2 rows here. So I want to do like, P on the bottom, Q on the top, and then A on the top, and then W on the top, Y on the bottom, and S on the bottom. So I can probably just do the top row to the top row of pins and the bottom row to the bottom row of pins, and then interleave the middle row, top, bottom, top, bottom, top, bottom as we go. Okay, I can do that. So this is U1 on this side, and we're going to start with the QWERTY side. So U1. All right. No, but I didn't do them. Oh, blast. Okay. QWERTZ UIO. Hey, you know what? I'm going to bring this up. Enigma keyboard. Images for Enigma keyboard. Hey, look. Lots of images for an Enigma keyboard. But I can use that as a reference. So that's exactly what I'm going to do. Okay. So come back over here. Okay. So 28 and 1. Oh, geez. I'm going to be working out from here. Okay. So you guys move. You guys move. Okay. So I want Q to go to 28 because... Where is it? There it is. Q to go to 28 because 28 is on the left-hand side. So it's 28 down to 21, but it's 1 down up to 8. So yeah, that's going to be interesting. All right. So I want Q to go to 28. I want P to go to 1. And then I want A, we'll start out with the top row to 27. Okay. Next row. W goes on the top row, which is there. I want Y on the bottom row, which is there. And then I want S, which is the middle row, there. Okay. And then I just got to interleave them like this. WSY, and then EDX. So E is on top. E goes there. X is on bottom. And then the middle row is D. We're going to go to the top for now. And then R is on top. C is on bottom. And then the middle row is F. Goes on bottom this time. And then T, G, V. So T is on top. V is on bottom. And G is in the middle. We'll put that on the top this time. Um, and then I'm just going to go ahead and do it like that. And then this one will, I'm going to start, how do I have the chip oriented? Yeah, so I've got pin 1s facing away from each other. So all the I2C and power stuff is in the middle and all the GPIOs on the outside. So on this side, I'm going to be doing like OKL will go to the 1 and the 28. All right, so we're going to do it the other way. So 1 and 28. So I'm going to start with O. And 1's on top now, isn't it? Yes, 1's on top. So the top row, and then L is on the bottom, and then K is in the middle. Okay, and then I is on the top, which is there. M is on the bottom, and then J is in the middle. U is on top there. N is on the bottom, and H is in the middle. And then Z is on top, and B is on the bottom. Okay. So that is, I think, the most efficient mapping I'm going to be able to do right now. So let me save those changes. Let me save a netlist, generate. Yep. And then we come back, new. There. And we are going to read a netlist. Okay. Now, if I try and lay some copper. Yoink. It is now picking up the new traces. Now, Y goes on the bottom, so I'm going to want to thread the needle here. Hope it lets me do that. Yay, it is. Yay, Zoidberg. S goes to the bottom. Let's give myself some space here in case we need to route more traces through here. And then X, oh shoot. How's that going to work? I need to pass unless I run E right down the middle of the X plug board, like that. That, I don't know how sustainable that's going to be. We might run into a creeping problem. We'll see. Where's F? F goes right there. Might have to tighten up some of these traces here. Going vertically, running out of space. Although I guess I only have 3 more here. All right, well, yeah, but I only don't have the space for 3 more. Oh, haha. Nope. Shoot. I mean, I could just move the chip if I had to. Interrupt. So all of those can go down, I think. I can also run some of these on the bottom if I want to. I kind of don't want to, though. And then G. Yeah, don't like that. Too close. And I don't have a corner on that one. All right. Is this going to give me enough space? Oh, hold on. What I actually want to do is move that there. Can I do that? Like that. And then that there. That there. That there. Okay. Now we're on to something. This will give us plenty of space. This is one of those things that KiCad does not do as well as some of the other alternatives. Moving traces around is kind of a raging pain. Whereas Eagle, oh shoot. Okay, good. Whereas Eagle, if I remember correctly, you can grab a straight edge like this and just grab it and pull it up without it going to the nearest nearest joint. So, and that one I'm just going to delete because I wanted to add a bend there. That's the other thing, is that you can't really add joints, or if you can, I haven't figured out how to do it. Okay, now this one, if I remember correctly, goes up, threads the needle. Okay. All right. Now I have space for G. There we go. All right, so let's take a look at that. Oh, sorry for you guys. Complete with sound effects. They're important. Life is better with sound effects, aren't they? Okie dokie. So L. Oh. It's a little bit weird. Maybe not. Gonna make sure and leave myself a whole bunch of space so I don't run into the same problem on this side. Although, honestly, there are many fewer letters on this side, so I'm less concerned about it. But I'm still going to pack these. Crap. Got to get M over there first. It's gonna be another case where I'm going to have to thread a trace through another plug board. I got a few of those. If I paid attention to this layout, I probably could have avoided that, but that's okay. Because I think this is where things are going to start getting cozy. J. U. Oops, too far. N. Got another threading here. And H. Oh, no. Nope, I'm good. And B. Where is my Z? All right, I'm going to have to thread Z through B. That's fine. We can do that. Or Z for all of my proper English-speaking listeners, followers, readers, watchers, whatever you guys are. Okay. I think that's it. Those go over there. These go over here. I think that's my Enigma. Let's put some planes down. On the front copper plane is going to be ground. Front copper, ground, okay. Normally we put ground planes on the bottom side, but since I've got a bunch of surface mount stuff that needs to connect to ground and a bunch of through-hole stuff that needs to connect to VCC, I'm going to put ground on top and VCC on bottom. That way I don't have to do any vias. Oops. Let me start that over. Bottom, VCC, go. All right, run a DRC so that you can lay out the copper. Yoink. Da, 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 da. All right, all my VCCs are run. All of my grounds are run. Let's take a look at our layers individually. That is our top layer. That's our ground. So all of the resistors are tied to ground. So we've got these thermals here, right? So all of them have thermals. There's no ground. There's no section where a ground plane has been lopped off from the rest of the board like this, right? Because there's no place to get a ground in there. But we don't care. We don't need ground right there. So that looks good. All the grounds are tied. Let's look at the bottom, which is the VCC. I got to tie those pads of the capacitors. Wait, what? Which side of the board are those caps on? Those caps are on the top side of the board. That is not going to work out so well there. Those are going to have to get moved. Okay, move and flip. Where are you going? VCC, ground, ground, ground. Oh, no, those are, okay. Yeah, right there. And then move. What are you? Capacitor. Okay, flippity flip. And all right, so now you should show up on the bottom. Ka-choink. Okay, so VCC tied to VCC. That's very good. VCC tied to VCC. Let's put some grounds in there. Okie dokie. So start on the bottom layer. Go there. Do plus to bring you a via. Okay. Same on this side. Click there. Plus to give me a via. All right. Now do another DRC. Do we have any unconnected? We still have some unconnected. Oh, because I haven't done SDA, SCL, and the interrupt and the resets. Okay, so I haven't hooked up the header yet. That's fine. But more importantly, did we get a charge? So I've got a ground via right there that's connecting to the chip, and my resistors are underneath on the bottom side of the board, or I'm sorry, the capacitors are on the bottom side of the board, out of the way. All right, well, I don't need to look at the ground planes anymore, so make those go away. So all of that up there is done. And according to my design rule check, it is complete. So we have SCL and SDA. I don't have to worry about grounds and powers. I do need to worry about interrupt and reset. I want those all of these to be put in parallel. So I'm going to do that. I know that's not going to work because I'm going to need to get the other one through here as well. Whoa. Oh, what do you know? That worked. Bum, 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 bum. Interrupt. Oh, convenient. And I've just cut off ground, haven't I? That ground just got cut off. VCC is on the bottom layer, so I'm not worried about it, but the top layer of these grounds just got lopped. So what I'm going to do is this. Wait a minute. Nope, 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 nope. Even better. Because now I can take that interrupt line and do the same thing. Too close to the pad. Oh, fine. Gotta give myself some more space up here. All right. So that should keep grounds connected around to the outside. Let's take a look. Yeah, see, ground is connected there. I don't like the fact that it's not connected over there, that it has to go all the way around. I guess it's not all that far around. But still, I'd feel better if that were connected. So I'm probably going to move that around so that I can get some more space on that. Okie dokie. So I got interrupt and I got reset left to do. Okay. Where's the reset? There's reset. Oh, phooey. All right. Glad I gave myself some extra space around here. Oh, wait, hang on. Because that is going to have to go like this. Blast. What? Except that that's totally going to cover up. Disconnect the grounds. What did I just do? Yep. So now I've got my ground. My ground source is right there. And it's going to go up and feed this chip just fine. It'll come over here and feed the interface, the address selection chips over there. But to get over to this side where the chip gets its power, it has to go all the way around up here because these are all getting chopped off. All the way to the top of the board and then back down again. So yeah, I definitely need to move that board edge to give this ground plane some more space here. There's no place to edit the corners. Damn it. Is drag what I want? Oh, maybe it is. Okay, so that's connected more directly now. All right. If I'm seeing this correctly, I've only got one more pin. Shoot. And it has to go under there. One more pin to route. Copper layers only. Fine. Oh, here we are again. All right, forget it. Boom, boom, boom. So I just found out how to resize copper planes. That's good. But I am going to run this reset line on the bottom. And I'm going to go back to the top when we're done here and see if there are any other lines I can run along the bottom that will make more sense to do so. Like that other reset over there that went all crazy, hey wonky. All right, so I need to make sure not to chop VCC planes in half. So if I come around, I want to make sure that that VCC and that VCC stayed well connected to that one. So if I go like this, Just kidding. And get rid of that wild and crazy trace. Hey, no one connected. That's nice. All right, what is my bottom? Okay, so VCC is there, VCC is there. It still has a good connection. Yeah, I'm happy with that. That's got a good connection, those two right there. That's kind of the important ones. Blah-bitty, blah-bitty, blah. Are there any other traces from the top that I really ought to be doing? Like maybe interrupt. SDA, SDA in the middle, SCL, SCL on the outside. There might be better ways of doing this. Yeah, I'm starting over. The reason is that I'm noticing that SCL and SDA are parallel here. I can just run these traces in parallel down here, and then int I can also run right next to it in parallel. And then I think I can go out from here up like that and around. And I think I can have them all in parallel, and I don't have that weird like T-shaped stuff. Okay. Oh, nope, nope. I'm putting this on top. What? Okay. There's an extra trace under there, but that's all right. So which one is it that I have? Reset is taken care of, so I don't have to worry about reset. But let's do interrupt. Okay. Now, bum, 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 bum. I want to move that one over here. Oh, sure, we'll do that. And then interrupt comes down there. Yeah, I think I'm just going to do interrupt like I had it before. Okay, let's see what that makes the ground planes look like. First off, nothing unconnected. Okay. Show me the ground plane. Hey, that looks a little cleaner. That looks a lot cleaner. Ground and ground and ground. Ground has to go through here, but that's okay. That's not too far out of the way. Ground still connects over here to that ground. Those grounds are just signal ground. They're not power ground, so I'm not too worried about them. All right, that looks good. Let's look at the bottom layer. So VCC is all... Got a VCC there, VCC, 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 VC, VC, VC. Yeah. That's looking pretty good. One last DRC. Are we... Nothing unconnected. Okay. I think we might be done. That's going to be $100. What did I miss? Anything else in here that I should be paying attention to? I got my buttons. These are going to be kind of tall. They're going to be a lot taller than the LEDs. Although the plug board's going to be a little weird. So the plug board is going to be a bunch of 2-pin headers that have a twist in them. So I'm going to be using the Molex keyed 2-pin headers. I'm going to be using the Molex keyed 2-pin headers that have, it's like a block like this, but they've got the two little things on the sides. And then the wires have a rollover in them. So Q will connect to S, for example, and anything coming down from Q will go over to the S going down to the chip, and anything coming in from the chip on the S will go over to the Q going up, right? So basically it's just a way of arbitrarily swapping pairs. Then that means that if you, normally in the real Enigma, if you don't plug something into the position on the plug board, it just immediately connects it straight through. In this particular case, we're going to have to put plugs on there that just loop back. But that's okay. So instead of having an empty plug, you're going to have a loop back plug that'll just go straight in for a straight through plug. So those are going to have kind of wires jumbled and connected and funky things. So that's going to take some space. These buttons will be taller than the LEDs, certainly. But again, this is just a proof of concept. This is just a, does it work? And then we will lay out, a proper board with an actual microcontroller and a display on it later if we want to, if it ends up working out. Yeah. Oh no. I got some silkscreen work I want to do. But it's getting late. I've been doing this for a little over an hour now, and it's about time for me to go into bed pretty soon here. So what I'm going to do is I'm going to call it a night here. I do have some more work I want to do. I want to clean up the silkscreen because I got a bunch of like the, like the diode numbers D8, and they all say K. Not entirely sure why they all say K, but D20, D26, D21. I don't care about that. What I care about is the U and the Z and the T and all that. And that's the yellow text is not going to show up on the silk screen. So I got some silk screen work I need to do on this before I'm ready to order it. So I'm definitely not going to order it tonight. But I've made some good progress. I've got the traces all there. I know the board can lay out in a sane way. And I think it's pretty close. And we only have the 6 pins to connect through to microcontroller. Power and ground, I2C, the clock and data, and an interrupt pin and a reset pin to be able to control both of those chips. That makes me pretty happy. I'm pretty comfortable with how this all turned out. So I'm going to call it a night. Thank you very much for watching. Go ahead and subscribe to me here on YouTube if you want to keep watching these. These Enigma videos are landing in a playlist, so you can see all of the work I've been doing on any given project. All of my projects are, I put playlists for the project, so you can go start to finish and watch the whole progress if you want. This will be in there. if you have any questions for me or want to give me any feedback or death threats or anything else like that, whatever, hit me up on Twitter is probably the best place, at Smitty Halibut, SmittyHalibut. And that's the one place that I read pretty religiously. It's definitely mentions, and I also accept direct messages there if you want. But hit me up on Twitter, or you can hit me up in the comments down below in the YouTube. That'll work as well. I do check those periodically. Yeah. I don't know what I'm going to be working on next. I kind of go back and forth from project to project to project a lot. But this one is one that's kind of been on the back of my mind for a while. I've been wanting to make an Enigma, a little pocket Enigma that people could use. And it's real easy to do it in software. There's one called, was it Arduino Enigma? Enigma Arduino? Something like that. It's Arduino controller with a little LCD screen on top of it, like a 3.2 inch LCD screen. Not one of the character LCDs, but it's a graphical LCD, and it actually looks really nice. It looks very similar to an Enigma. Excuse me, but it's all in software. That's the only hardware are the I think it's even a touch screen, so there really isn't any hardware that's doing the Enigma emulation. I like this one in that it is implementing it the way the Enigma actually did, and all we're doing is we're replacing the rotors with the microcontroller. But the rest of the system is happening the way the Enigma does. So it's somewhat unique in that regard. So anyway, beating a dead horse. Like I said, hit me up on Twitter with questions or comments. I'd love to hear from you. I want to hear what you're working on. Tell me what kinds of projects you're doing. Tell me the problems you've run into. Tell me how you overcame them. Give me all the nitty-gritty detail. I want to hear it all. Thank you so much for watching, and I will catch up with y'all next time. Have a good one. Be good humans. So here's the weird thing, that if I hit stop streaming now, it's going to be a while before the stream catches up. And I think when I stop streaming, it actually, it's been complaining about stream health. Who? Your YouTube is not receiving enough video to maintain smooth streaming. As such, viewers will experience buffering. Is that on my side? Is that on YouTube's side? That would explain why I'm so far behind on the stream. According to the stream, I'm still laying out the first reset trace. That doesn't look right. So you're getting a little extra post-show here. On the stream, it looks like I am still worrying about the reset trace. I haven't taken care of the reset trace yet. I'll probably cut this off later. Oh, I've got 2 viewers now. That's spiffy. All right, I'm going to go ahead and stop the stream here. So I will catch you all later. Hopefully this doesn't chop off the video. I know I've had problems with video streaming in the past with bad buffering, usually when I was in a hotel room though. So, but I'm at home now. I should have plenty good internet for this. I don't know if maybe my wife is streaming from the other room, but